PH4410 review on the minimal spanning forest algorithm. In the previous video reviews, we have gone through correlation filtering methods like spectral filtering, threshold filtering, filtering through the construction of a minimal spanning tree, as well as the construction of a planar maximally filtered graph. Now we move on to time series clustering methods. And obviously for threshold filtering as well as spectral filtering, these are by themselves already time series clustering methods. But the minimal spanning tree and the planar maximally filtered graph, they produce connected graphs always, and therefore are not necessarily clustering algorithms by themselves, but with a small modification we can make them so. So for the minimal spanning tree, if we make just one small modification to the algorithm, we will end up getting the minimal spanning forest algorithm, which will produce not just a single tree, but many trees that are disconnected subgraphs. So we look at this algorithm in greater detail in this review. So first, let us note that the starting is still the same. So we start from the largest cross correlation Cij, and then we draw a link between I and j. Okay, then in the second step we go to the next largest cross correlation Cij, and if either I or j has never been incorporated into a subtree at a previous step, then accept the link between I and j, else reject. Okay, and then in the third step, again we will stop if all nodes have been incorporated into one of the disconnected tree graphs. Okay, else repeat step number 2. Okay, so this is the algorithm. The only difference between this algorithm, the minimal spanning forest algorithm, is the fact that either I or j have not been previously incorporated into a subtree at the previous step. We don't need to worry about cycles forming, because this condition is actually a lot more stringent than the cycle condition. So let's see how this algorithm works in practice. Let's clear the page and copy the example that we had used earlier on. Okay, so this is the example that we have been using all along. Let's first get rid of the diagonal. Let's get rid first of the diagonal, and we're only interested in the upper diagonal. And of course, through so many doing this example so many times, we know that the largest correlation value is 0.88, which is this one here, between number 8 and number 6. So we draw that. So let's draw 6 and 8 and link them. Next, the next largest cross correlation is 0.865 here. Okay, this is between 3 and 2. Between 3 and 2. So let's draw that as well. So this is between 2 and 3. And the next largest cross correlation is 0.85967. This is between 7 and 4. Okay, and we have seen earlier on where we would want to draw this. So this is 4 here, and then 7 here. So far for these three cross correlations that we have considered, the nodes that are that are added, they are both new. 6 and 8 were both new. Was never been previously incorporated into a tree at a previous time step, and then 2 and 3 has never been incorporated into a tree at a previous time step, and the same is true for 4 and 7. That's why we can just immediately accept the link. Now let's go on and see whether we would encounter the alternate condition in the minimal spanning forest algorithm. So I think we have exhausted correlations above 0.8. There is just one correlation. There's just one correlation above 0.7, and that is here between 8 and 4. And so this is the key. So 4 and 8 both have been incorporated into separate subtrees, and therefore they no longer satisfy the condition for the minimal spanning forest. So this link cannot be accepted. So we do not draw this link here. So there used to be a link here, but now this link is not accepted. So we go on down the cross correlations. So we have 0.66. and we have 0.6269. So this is the next largest cross correlation between 7 and 1. Okay, between 7 and 1. Now 7 of course has been previously incorporated into a tree, a disconnected subtree, but 1 is new. So we can actually draw the link between 7 and 1. Okay, 7 and 1 because of the fact that 1 is new. So this is accepted. Now the next largest cross correlation is 0.66 here. Okay, so this is between 4 and 2. Between 4 and 2. Now 2 and 4 both have been previously incorporated into their own subtrees, and therefore this correlation, this link cannot be accepted. So if you recall, we used to have this link here, and this is also not acceptable. Then the next largest will be between 4 and 1. Between 4 and 1, but 4 and 1 have already been included into, in fact, the same subtree. So again, we ignore this and proceed to look at the correlation 0.62491. Okay, this is between 8 and 3. Between 8 and 3. Again, 8 and 3 have both been already included into their respective subtrees. So this is to be ignored. This is to be neglected. We will skip this correlation to go on to 0.61. This is between 5 and 2. Okay, so this correlation is between 5 and 2. Now, 2 obviously is not a new node, but 5 is. 5 has never been incorporated into any subtree, so we can include now 5 and then draw the link to 2. Okay, so this is acceptable, and then of course if we proceed, then we will find that 5 and 1, but this is not acceptable because 1 and 5 are not new anymore. And then we can keep going down, and we'll see that we will never accept another cross correlation again. The reason for that is because all the nodes 1, 2, 3, 4, 5, 6, 7, 8 have been included into the minimal spanning forest. which consists of actually one tree here, another tree consisting of only 6 and 8, and then finally a third tree consisting of 1, 4, and 7.